Hello, welcome to Buildings of Tomorrow. My name is John Lester, and in this episode we'll be focusing on hydronics and the different ways that hydronics systems are developed and designed so that we can deliver our energy at the right place in the right time. I'm joined in the studio by Chris Kopp, an expert on hydronics and HVAC theory. Chris, thank you very much for joining us.
My pleasure, John.
We've spoken before about hydronics and how it's the platform of what buildings are built on, the success of buildings and the delivery of energy to the space. What are the different ways that hydronic systems are designed?
Okay. Yeah, as you just said, I think that the hydronic setup, the hydronic system is really the foundation to deliver the right amount of heating and cooling from the production through the distribution all the way out to the consumers. And now when we want to do that, we have to think about how can we adjust this capacity, because we don't need the full capacity throughout the year.
Yeah, it's not always the same, correct?
Yeah, sometimes we need more, sometimes we need less.
Yeah.
And the full capacity is probably the case that doesn't happen at all throughout the year, right?
Okay.
Most of the time we run what we call at part load conditions.
Okay.
So we need a way to adjust the capacity to meet the demands of the consumers.
Okay.
And we do that with different constructions of this piping network out at the consumers, and we call that different hydronic consumer circuits.
Okay.
And there are various ways to do that. When we think about it, to adjust the capacity, we have basically two ways how we can do that. We can either adjust the volumetric flow, bring more or less hot or cold water, and by that adjust the capacity, or we can play with the temperature difference.
Okay.
Make it smaller or larger, and with that transfer more or less heat or cool.
Okay, so you can either send more water to send more energy, or you can send colder water to deliver more cold energy, or hotter water to deliver more heat energy.
Exactly.
Okay, and how does that affect the actual physical construction?
Okay, so now based on this idea that the capacity is proportional to the volumetric flow or the temperature difference, we can derive different constructions from that. And so there are two main constructions for such a hydronic consumer setup that play with the volumetric flow. We call them throttling circuit. You can envision a pipe with a valve in it, and we just close it off or open it up as needed.
So a bit like the garden tap at home, perhaps?
Exactly.
Okay.
Like your water tap at home. If you want more water, you open it up. If you say, no, that's too much, you turn it down.
Okay.
So that's one construction, the throttling circuit. And then we have another circuit that also varies the flow across the consumer, but it is constantly supplied with the full amount of water. And we call that a diverting circuit, because we bring out the hot or cold water all the way out to the consumer, and out there we decide how much of it do we need. And whatever is not needed gets recirculated back to the production.
Okay, so what we don't use, we send back to where it started, but we've already sent it all the way there in the first place.
Right.
Okay.
And the reason for that, especially in the past, was to ensure that we have the heating and cooling available out there at the consumer whenever we need it. Right. But today we look at this setup a little bit different, because it doesn't make sense to circulate 100% of water flow all the time throughout the whole building, because that means the pump has to run constantly at full speed and also at full power consumption.
Okay.
And the second part is, by running the water throughout the building, we lose part of the heat, or we gain some of the heat if it's cold water network, and that is basically lost capacity, which then has to be reproduced by the producer. And so because of these two topics, it's not an energy efficient way to do
No,
that.
it sounds like we would waste a lot of energy that we didn't have to waste in the first place.
Actually,
Okay.
just to make sure, in case it's needed, we have it available.
Yeah.
Right. So today we want to go away from that. But we have these two circuits for adjusting the volumetric flow, and by that changing the capacity. The throttling circuit and the diverting circuit. Now, when we look at the other variable, the temperature difference, we also have different setups.
Yeah.
And the one that is for a lot of people well known is what we call the mixing circuit. Mm-hmm. It's very often used in normal heating systems, and it means we mix the warm water from the boiler together with the cold return water, to the desired temperature, and by adjusting the temperature and also playing with the temperature spread, we can adjust the capacity in the consumer.
Okay.
So these mixing circuits are widely used, especially in heating systems. And they have an internal pump to circulate the water across the consumer. And this pump also is responsible for getting the right amount of water from the production side.
Okay.
And of course, it can only do that if the production is very close by to the consumer circuit.
So going back to an example that, like we used before with the house, this is like our mixing tap in the kitchen. It picks enough hot water and enough cold water and mixes together to make the right temperature.
Absolutely.
Okay.
Absolutely. And we try to do that for the supply temperature to our room heating system.
Perfect.
For example.
Yeah.
Right. And then we have two more constructions that vary the temperature difference. One is the injection circuit with a two-way valve, and one is an injection circuit with a three-way valve. And the main difference is, when we look at it from the consumer side, they act the same. They mix water by injecting a certain amount from the supply side into a continuously running circuit across the consumer.
Okay.
So from the consumer perspective, both are the same.
Yeah.
Where they differ is how they get the water from the supply side, from the production. The one with the two-way valve has a variable flow between production and the consumer.
Okay.
And of course needs also a variable speed pump to do that.
Yeah.
And the other one has a constant flow between production and consumer. And when you look at this part, it looks exactly the same as the diverting circuit we talked before. And now you can imagine that this is also something we don't want to do anymore.
Yeah.
So when we look at this, we can basically say we would like to have throttling circuits to vary the flow, and either work with mixing circuits or the injection circuit with two-way valves to play and vary with the temperature.
Okay. Perfect. So we have the hydronic circuit, or the hydronic system, which forms the basis of the delivery of energy to the room, so that our consumers are in the right temperature when they need to be. And we can either vary the volume or we can vary the temperature to ensure that we deliver the right amounts. And behind those, there's a few different things that we can do, but there are some preferences. So using some variable flow in both cases so that we're only providing enough energy to the field and not too much.
Exactly.
Perfect.
Absolutely.
Thank you very much for your time.
Thank you.
And thank you all for joining us here on Buildings of Tomorrow. Feel free to like, comment, or share this episode and subscribe to us here on this channel. My name's John Lester. Thank you for joining us.